Good morning to all. Welcome to Daffodils Science PU College. PU second year physics, chapter name Dual Nature of Radiation and Matter, class number 11. Today's topic that is about the numerical questions. All of you read the question number 11, that is a 100-watt sodium lamp radiates energy uniformly in all directions. The lamp is located at the center of the large sphere that absorbs all the sodium light which is incident on it. The wavelength of the light is 589 nanometer. Then A. What is the energy per photon associated with the sodium light? B. At what rate the photons delivered to the sphere? In this question, they have given a sodium lamp which is emitting the radiation, and the power of the sodium lamp is about 100 watt. Write that one. That is, the power of the sodium lamp is equals to, that is capital P is equals to 100 watt. The wavelength of the light they have given, that is about 589 nanometer. Write that value. That is, wavelength of the light is lambda is equals to 589 nanometer. 589 into 10 to the power minus 9 meter. Next, what is the energy per photon associated with the sodium light? What we have to calculate? Energy per photon. If you want to calculate the energy per photon, what is the mathematical equation? There is energy is equals to hc by lambda. H is what? Planck's constant. C is what? Speed of the light. Lambda is what? Wavelength of the light. Now substitute the Planck's constant, that is H is equals to what? 6.63 into 10 to the power minus 34. C is speed of the light, that is 3 into 10 to the power 8. And wavelength of the light they have given, that is 589 into 10 to the power minus 9. Substituted. After this one, do the simplification. In the numerator, 6.63 into 3, that is equals to 19.89. divided by 589 as it is. Take this denominator power, that is 10 to the power minus 9 to the numerator, that will be 10 to the power plus 9. Now add all the powers. Now add all the powers, that is 10 to the power minus 34 plus 8 plus 9. When the bases are same, powers will be added. Next, do this simplification. Take this ratio, that is 19.89 divided by 589. You will get around, that is 0.03377 into 10 to the power minus 34 plus 8 plus 9. And the power, calculate the power, you will get 10 to the power minus 17. This is the energy per photon, that is energy is equals to 0.03377 into 10 to the power minus 17 joule. Next we have to calculate the at what rate are the photons delivered to the sphere. Near a sodium lamp, they have placed a large sphere. Whatever the sphere is there, that is absorbing all the sodium light which is incident on it. Then we have to calculate that at what rate are the photons are delivered to the sphere. Means that sphere is receiving them. Means that photons are delivered to the sphere. We have to calculate in 1 second how many photons are delivered. That is, here at what rate are the photons delivered to the sphere? There is nothing but a number of photons delivered to the sphere per second. Number of photons divided by time, that is nothing but n by t. We have to calculate the number of photons divided by time. We know that is E is equals to hc by lambda. This is the basic energy of the photon. Next, if n number of photons are there, then energy due to the n number of photons is given by E is equals to n into hc by lambda. This is only due to the one photon. If n number of photons are there, we have to take energy is equals to n hc by lambda, where n is number of photons, h is Planck's constant, c is speed of the light, lambda is wavelength. Now divide the above equation with time on both sides. Whatever the equation is there, whatever this equation is there, that is E is equals to nhc by lambda is there, divide this one with t, with time on both sides. What you will get? E by t again is equals to nhc divided by lambda, divided by what? T, that is nhc divided by t lambda. T is nothing but here time. We know the power definition, there is nothing but rate of doing of work. Here work is nothing but here energy, so that power is equals to energy by time. Now in place of energy by time, in place of energy by time, we have substituted the power. It is not momentum, remember the term, that is power. Power is also indicated by P. Now n by t hc by lambda. Next, power is equals to n into E divided by T. Why you have written the E here? We know the basic equation. E is equals to what? Hc by lambda. Now in place of hc by lambda, substitute the symbol, that is energy. Now n by T as it is into E. Now what we have to calculate? We have to calculate the n by t, that is number of photons divided by time. So that keep this one as it is, take this E LHS. What it will be? Power divided by energy is equals to number of photons divided by time. Now simplify this one. Number of photons per time or per second is equals to power divided by energy. Have they given the power value? Yes, in the given question, they have given the power value. Check that one. The power value, what is the power value here? Power of the sodium lamp is equals to 100 watt. They have given here, substitute that one. And already we have calculated the energy also, that is equals to 0.03377 into 10 to the power minus 17. Now substitute these two values in the given formula, that is n by t is equals to p by e. Now power value is 100, that is a given value, and energy we have calculated. Substitute this one and you will get nearly 2961, and take this denominator power to the numerator, we will get 10 to the power 17. That is n divided by t, number of photons with respect to the time, is equals to 2961 into 10 to the power 17 powers, that is photons per second. How many photons will be delivered to the sphere per second? Nearly 2961 into 10 to the power 17 photons per second. This is about this numerical. Here we have solved the energy per photon along with at what rate the photons are delivered to the sphere. Now we will move to the next numerical, that is numerical number 12. They have given, that is monochromatic light of wavelength 632.8 nanometer is produced by a helium neon laser. The power emitted is 9.42 milliwatt. What we have to calculate? They have given the three questions, that is A, B, C. Find the energy and momentum of each photon in the light beam. What we have to calculate? Energy along with momentum of the each photon. Next, second one. How many photons per second on the average arrive at a target irradiated by this beam? We have to calculate number of photons per second. Next, how fast does a hydrogen atom have to travel in order to have the same momentum as that of the photon? We have to calculate the speed of the hydrogen atom, so that this must have the same momentum as that of the momentum of the photon. That is about the part C. Now we are going to solve the first one, A. Write the given data, that is they have given the wavelength of the light. Have they given the wavelength of the light? Yes, in the starting itself only they have mentioned, that is about 632.8 nanometer. That is in terms of the SI unit, that is 632.8 into 10 to the power minus 9 meter. 10 to the power minus 9 is the power used to indicate the prefix nano. Next, they have given power emitted is 9.42 milliwatt. 9.42 milliwatt. milli means what is the power? That is 10 to the power minus 3. 9.42 into 10 to the power minus 3 watt. Now A, what we have to calculate? Find the energy. We have to calculate the energy. Energy is equals to what? Hc by lambda, where h is Planck's constant, c is the speed of the light, lambda is wavelength of the light. Substitute all these and simplify this one. H value is what? Here I have written 6.63 into 10 to the power minus 34. C value is what? 3 into 10 to the power 8. Next, lambda value is what? 632.8 into 10 to the power minus 9. Now in the next page we are going to simplify this one. First you calculate the 6.63 into 3, that you will get nearly 19.89. Again in the denominator whatever the value is there, you write that one. 19.89 divided by 632.9 and simplify this power also, that is 10 to the power minus 34 into 10 to the power 8 into 10 to the power 9. Whatever this 10 to the power 9 is there, that is taken from the denominator to the numerator. In the previous step we have observed that in denominator 10 to the power minus 9 was there, but when you take this one to the numerator it will become 10 to the power plus 9. Now simplify this one. 19.89 divided by 632.9, that is 0.0314 into, simplify all these powers, that is x power m into x power n is equals to x to the power m plus n, that is 10 to the power minus 34 plus 8 plus 9, that is equals to 10 to the power minus 17. Next we will move to the Next we will calculate the momentum. Momentum is indicated by here small p. Why? Because already we have taken the power. Power is indicated by the capital P, so that here you make momentum as the small p. Now from the de Broglie wavelength we know that one lambda is equals to h by p. From this one p is equals to momentum is equals to h by lambda. Here p is what? Momentum. But in the next B part we will use the capital P as the power. Remember that one and make the difference. Now substitute the h value and substitute the lambda value. H is what here? 6.63 into 10 to the power minus 34 divided by lambda. Have they given the wavelength of the light? Yes, in the previous paper you can observe that the wavelength of the light is about 632.8 nanometer. Substitute this value in the next step, that is h value here and lambda value here. Now simplify this one. 6.63 divided by 632.8, you will get certain value and write that one, that is 0.01047. Next simplify the powers also. In the numerator 10 to the power minus 34 is there, the denominator 10 to the power minus 9 is there. 10 to the power minus 34 into 10 to the power 9, that is equals to 10 to the power minus 25. Again here the momentum of the photon is equals to 0.01047 into 10 to the power minus 25 kg meter per second. Next we are going to calculate the B. How many photons per second? Now number of photons per second, or as here number of photons divided by time. Already in the previous numericals we have followed the same thing, so that here also we will follow the same thing. We know that energy is equals to h nu, or as energy is equals to hc by lambda. Energy is equals to what? Hc by lambda. If n number of photons are there, we have to make that one as a n hc by lambda. Just observe in the previous numerical, that is here I have written clearly E is equals to hc by lambda. E is equals to hc by lambda. Here if n number of photons are there, E is equals to nhc by lambda. Then divide the above equation with respect to the time, that is E divided by time, nhc divided by time, that is equals to power. Here E by T is taken as the power. Power is equals to nhc divided by time into lambda. hc by lambda is taken as the energy. Here power is equals to ne divided by time. Take this E, that is energy, LHS, what it will be? Power divided by energy is equals to n divided by time. N is nothing but number of photons, T is nothing but a time. Okay, so that n by T, observe this equation. What is that one? N by T is equals to power divided by energy. We will use the same formula and no need to write entire that derivation. Remember that one, n by t is equals to power divided by energy. Power is indicated by the capital P and energy is indicated by the E. Substitute the power value. Have they given the power value in the given question? Yes, they have given. The power emitted is 9.42 milliwatt. Milli is indicated by here capital that is small m, and its power is 10 to the power minus 3 watt. That is capital W is nothing but a watt. Now here power value, substitute that power value, that is 9.42 into 10 to the power minus 3, and energy value 0.0314 into 10 to the power minus 17. Now simplify this numerator and denominator value, that is 9.42 divided by 0.0314. You will get nearly 300. Next, in the numerator 10 to the power minus 3 is there, and in the denominator 10 to the power minus 17 is there. Take this 10 to the power minus 17 to the numerator, you will get 10 to the power minus 3 into 10 to the power 17. That is equals to 10 to the power of 14. Again use that same formula, x to the power m into x to the power n is equals to x to the power m plus n. That is minus 3 plus 17. What that will be? Plus 14. Now number of photons per second is equals to 300 into 10 to the power photons. How many photons will be emitted per second? Here we got the answer, that is 300 into 10 to the power 14 photons will be emitted per second. Next we are going to solve the C. What is that one? They have given how fast a hydrogen atom have to travel in order to have the same momentum as that of the photon. Means that we have to calculate the speed of the hydrogen atom, so that hydrogen atom should have the same momentum as that of the photon. Means that they have given momentum of the photon must be equals to momentum of the hydrogen atom. That is momentum of the photon is equals to momentum of the hydrogen atom. In order to acquire this one, in order to acquire this condition, what we have to calculate? We have to calculate the speed of the, or else velocity of the hydrogen atom. Now we know the value of the momentum of the photon, already we have calculated in the A, that is by using the formula lambda is equals to h by p. That is a p is nothing but here momentum. Remember this one, p is what here? Momentum. But in the previous one, that is a capital P we have used, that is indicating the power, so that no need to get confusion. Here from this one, P is equals to h divided by lambda. Substitute the h value, substitute the lambda value, and we will get nearly 0.01047 into 10 to the power minus 25 kg meter per second. Already we have calculated this value in the A. You can observe here. Yes, already we have calculated this one, substituted the h value, substituted the lambda value, and we got momentum is equals to 0.01047 into 10 to the power minus 25. We are using this value in the C. Now here P is equals to, we have written the same value here, that is P is equals to 0.01047 into 10 to the power minus 25 kg meter per second. Now momentum of the photon is equals to momentum of the hydrogen atom, so that whatever the momentum of the hydrogen atom is there, that must be equals to momentum of the photon. So that momentum of hydrogen atom is equals to 0.01047. In the given question only they have mentioned momentum of the hydrogen atom must be equals to momentum of the that is a photon, so that we have written momentum of the hydrogen atom is equals to momentum of the photon only. Now momentum of the hydrogen atom, momentum is equals to what? Product of mass and velocity is equals to same value here written. Next velocity is equals to, take this mass term to the RHS. What it will be? It will be in the denominator, that is 0.01047 into 10 to the power minus 25 divided by mass of the hydrogen atom, that is nothing but 1.67 into 10 to the power minus 27 kg. Next, simplify this one, that is 0.01047 divided by 1.67. What we will get? 0.00627 into 10 to the power minus 25, and take this 10 to the power minus 27 to the numerator. It will be 10 to the power plus 27. 0.00627 into 10 to the power 2, and you can make this one as 0.627 meter per second. In order to acquire momentum of the photon, the hydrogen has to travel with a speed or with a velocity of 0.627 meter per second. Here, up to here, we have solved the numericals on the work function, threshold frequency, threshold wavelength, kinetic energy, later de Broglie wavelength, and when they have given accelerating potential and when they have given the kinetic energy, we have calculated all those things here. In these two numericals, we have calculated the number of photons emitted per second, or else how many photons are delivered to the sphere. Just follow all these things, practice all these models, and these are the numerical questions from the dual nature of radiation and matter.